Today, guys, we want to take a look at rational versus irrational numbers. So if we start with just whole numbers, such as, say, 7, or 25, or 130, okay? It doesn't matter what the whole number is. As long as it's a whole number, it is rational. Even if the whole number is negative. So if we have -3, -14, -220, as long as it's either whole, a positive number, or a negative number, then it is still rational. Okay? So as long as, like I said, there's no decimal, no fractions, anything like that, those are the easy ones, those are automatically rational. Alright? Now let's look at what we looked at recently. If we have a terminating decimal, so we have 4.8, okay? As long as the decimal ends, it terminates, it stops, these are also rational numbers. If the decimal goes 7.3, and that's repeating, okay? And if the number repeats, it is also rational. So if we had 4.121212 ... the 12 is really repeating. So that's 4.12 with the bar over it. That is still rational. So on decimals, if they terminate or if the decimal repeats, it is still rational. Any number that stops, so a whole number, positive or negative, and if it's a decimal and it terminates or if it repeats, it is also rational. That includes if it was negative. So negative would still be rational. Negative here would still be rational. Okay? Let's look at fractions. 1/3. 1/3 is rational. 4 1/2, so it's a mixed number. That is rational. Okay? If it was a negative fraction, -7/8, that is also rational. Pretty much any number that you can write as a fraction is rational. So we have all our numbers that are whole, positive and negative, are rational. Decimals that terminate or repeat are rational, positive and negative. And fractions and mixed numbers that are positive and negative are also are rational. So what is the irrational numbers? Irrational numbers are numbers that go on and on and on forever, that do not terminate, do not stop, or do not repeat, and they're in decimal form. So if we have 3.1718192643 ... Okay? So you notice with the dots, it's telling you it's going to keep going. Okay? But notice this one also had dots, right? But there was a pattern. It was 4.12 repeating. But up in here, there is no pattern of anything repeating. It goes 17, like 18, 19, 26, 43. There's nothing repeating. And it just keeps going and keeps going and keeps going. This is what we call an irrational number. Irrational numbers do not terminate, do not stop, they just keep going. The most famous irrational number is pi. Right? 3.14, 159, and so on. It just keeps going and keeps going and keeps going. Okay? So any decimal that goes on and on and on and on and on without stopping or repeating is irrational. If we had 0.07261 ... so on, that would also be irrational. Okay? Now, this is the ones that we have to be careful and look at. What about our square roots? Okay? So if it asks for like the square root of 25, this is where we ties in our previous lessons. Is there a perfect square root of 25? Well, yes. Square root of 25 is 5. So therefore, it is rational. Okay? But let's say we have this square root of 27. Is there a perfect square root of 27? If we put that on our calculators, reasserts it turns out to be 5.19 dot 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 dot, and it keeps going. So there's not a perfect square root of 27, and it doesn't terminate, it doesn't repeat, so this is irrational. Okay, so you're going to use your calculator a little bit on these, on the square root ones. These are the ones that we need to pay close attention to. Okay, so if I asked you if you had the square root of, say, 144, and is that rational and irrational? Well, you have to ask yourself, is there a perfect square root of 144? Well, yes, it's 12. So therefore, it's going to be rational. Okay, but if I ask you, let's say, square root of 101, is there a perfect square root of 101? Well, no, it's going to be 10 point something, 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 something. So that is irrational. All right. So you've got to look for the two different things. Okay. In your assignment, you're going to have, it's just going to be, make sure you do the Canvas quick assignment afterwards. There'll be a couple questions asking if this number is irrational or rational. And then at Alex, it's going to give you a bunch of numbers and ask you if they're rational or irrational as well. There is no assignment on reveal on this. Okay. So this is what you're going to be facing. If I give you number 7, I'm going to ask you, is that rational or is that irrational? Well, it's a whole number, so of course it's rational. If I ask you for the square root of 7, is that rational or irrational? Well, there is no perfect square root of 7, so it's going to be like 2 point something, da 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 da. So therefore, it's going to be irrational. If I ask you for 7/9, well, is that rational or irrational? Once again, any fraction pretty much is going to be rational. Okay. If I ask you for 0.7, well, it's a decimal that terminates, so it's rational. If I ask you for 0.7 repeating, or if I put 0.777 dot 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 dot, well, if it repeats, and that there's dots, and that there's a pattern, therefore it's going to be rational. If I went 0.712159 dot dot dot, okay, now there's no repeating pattern, so that would be irrational. Alright, there's one last thing to look at. I said that most all fractions are going to be rational, but you got to be careful. If there's an irrational number, let's say like pi in the fraction, well then that is going to be irrational. So if there's already an irrational number in it, it's going to be irrational. Square root of 2 over 3. Well, there is no perfect square root of 2. Okay, it's not 1 times 1. There is no perfect square root of 2, so therefore that is irrational. Okay, so you've got to be careful and also watch for those little tricks. All right. Remember, on Tuesday mornings, Miss Bolos and I are on there if you have any questions on this. But from that, I'll let you be.